Hi everybody, I am Pradyut Mukherjee from MMD Exams Guide, your shipmate to success. I shall be presenting various marine engineering and other marine related topics to help you in all walks of your life. So please view my channel, like my channel, subscribe for notification, share my videos, and please comment on my videos. Thank you. Hi everybody. Today we shall cover up the chapter of propeller. As you can see, yes, numericals on propeller. So here what you see is a photograph of a propeller. And if you notice each blade, let us consider this blade. If you notice this blade, if you see that the twist of the blade is maximum at the root of the blade. And then as we move away from the center of the propeller, this is the center of the propeller, we see that the twist of the blade is gradually reducing, and the pitch of a propeller is actually dependent on the twist of this blade. So, what is done? We calculate the pitch at this point, say P1, depending on the twist angle. Then again, we calculate the pitch at this two, P2. This is of different distance from the center. And let us say we calculate the pitch at another point P3. And then we take an average of all these three, and that gives us the pitch of a propeller. So let me explain with a little bit of a sketch. Okay, let us say this is the boss of a propeller, and we have got a blade out here. Let me take another view looking at the propeller from the aft. This is one blade and this is one. Let us consider this point of the blade and let us consider this part to be chopped off. And we are seeing only this part of the blade. And the twist of that blade would be somewhat like this. This would be the twist of the blade at this point. That would be causing a thrust for which the ship would be moving. Now let us draw a triangle. So this angle at the top, theta, this would be the twist angle. Now let us consider this point, and when the propeller makes one rotation, this is the distance that this reference point would cover. And what is this distance? This is nothing but 2 pi r. What is r? R is the distance of the reference point from the center. This would be r. And this 2 pi r is represented by the perpendicular in this triangle. And what is the pitch of the propeller? That is the distance that the propeller would move forward when it makes one rotation. So this distance obviously would be represented by the base of the propeller. That is the pitch of the propeller. Now let's see a better drawing. So this is the blade angle at which it is twisted at a certain distance r from the center. At this point, this is the twist angle theta. This is the distance that the propeller would move in one rotation, and the base is the pitch. So from this triangle, we can say that tan theta is equal to base by the perpendicular. This P is the pitch. So we can say that pitch of a propeller is tan of the angle pitch angle into 2 pi r. This is formula number one for this chapter for calculating the pitch at any point r distant from the center of the propeller. Similarly, we calculate the pitch at different points and then take an average of all that pitch, and that would give us the pitch of a propeller. And on top, you can see I've given the definition of the pitch of a propeller. It is the distance a propeller would move in one rotation if it worked in an unyielding medium. Yes, but the propeller unyielding medium means a solid medium, but the propeller works in a liquid medium which is yielding. So that gives rise to different types of slippages. So let us go to the next slide. And this is a sample numerical. You see that the pitch angle of the propeller is given at various radiuses. At 1 meter radius, say this is the propeller blade. So at 1 meter radius, the pitch angle is given as 42, and similarly at a distance of 1.5 meter the pitch angle is given as 32, at 2 meters it is given as 26, and so on and so forth. So how do we solve such a numerical? We make a table. So this is a table, and as you can see on the first column, we have written all the radiuses, the different points from the center of the propeller boss at which the different pitch angles are measured. The third column, actually, this should have been the second column. The third column, we are writing the different pitch angles at the respective radiuses. Second column, we are calculating the tan of these different pitch angles. We get the tan theta. Fourth column, we write the 2 pi r. That is the distance that that point of the radius would move in one rotation. That is 2 pi r. And finally, the last column is the pitch using the formula pitch equals tan theta into 2 pi r. We get five different pitches at five different points. Every point is different radius from the center. And we take an average of all that. We get 6.09 meters. The unit of pitch is meters. We shall round it off to 6.1 meters. So this is how the pitch of a propeller is calculated. Let us move on. Now we just saw that the pitch of a propeller is the distance that the propeller moves in one rotation, one rev. Okay. So then the distance moved in two rotations would be P into 2. In three rotations would be P into 3. In n rotations would be P into n. This would be the distance moved in meters when the propeller makes n number of rotations. Now suppose this rotation is made in 60 seconds, that is 1 minute, revolutions per minute. Then the distance moved in meters per minute would be P into N. This would be the distance that the propeller and the ship would move in 1 minute, provided the propeller is working in an unyielding medium. So, how much would the distance the propeller move in 1 hour, meters per hour? It would be P into N into 60. This would be the distance moved in meters per hour. But on board, we really don't measure the speed in meters per hour. We measure it in knots. So the speed of the ship or the propeller in knots would be P into revolutions per minute into 60 divided by 1852. This is called the theoretical speed of the ship because we are considering that the propeller is moving in a unyielding medium, which it is not. So this is the formula for theoretical speed of a ship. Let us So the distance moved in meters per minute would be pitch into RPM, as I just explained. Distance moved in meters per hour would be pitch into RPM into 60. And distance moved in nautical miles per hour would be pitch into RPM into 60 divided by 1852. And this is termed as the theoretical speed, which we shall denote by V and small t. As I said, that the propeller is not working in a unyielding medium. It is working in water. So there would be some slippages. The first slip is apparent slip, which is theoretical speed minus ship speed divided by theoretical speed into 100. Next is the real slip. That would be the theoretical speed of the ship minus speed of advance divided by the theoretical speed into 100. Now we see one new speed over here, that is the speed of advance. Now, what is the speed of advance? Let me explain to you. Let us say this is a ship, yeah, a plan view of a ship, and this is a propeller, and the ship is moving in this direction. When the ship moves, there is a small layer of water which moves along with the hull due to the viscous drag. But this layer of water moves not at the speed of the ship, it moves slower than the speed because it is not fixed to the hull. It is just a drag, and this water body extends like this around the propeller. This water body, which is around the propeller, is called the wake. So this wake, along with this layer of water, moves along at a slower speed than the ship. And the speed of the ship with relation to this wake, that is called the speed of advance. Because the propeller is working in the wake. The propeller is not working out here or out here. It is working in the wake. So the speed of the ship or the speed of the propeller in relation to this wake is important, and that is called the speed of advance. Let's move on to the next one, which is wake fraction, which is expressed as ship speed minus speed of advance divided by ship speed. And as this is a fraction, we don't multiply by 100 because it's not a percentage, it is a fraction. Let us see some more formula in this chapter. Wake fraction can also be expressed as this formula, where CB is the block coefficient, length of the ship into breadth of the ship to the draft of the ship divided by the volume, that would divided by the displacement, that would give us the block coefficient. Next we come to pitch ratio, which is a simple ratio of the pitch of the propeller divided by the diameter of the. What would be the diameter of the propeller? If this is the propeller, the other side just two blades, the distance from this tip to this tip, that would be the diameter of the propeller. Or if the when the propeller rotates, it describes a circle. The diameter of this circle is the diameter of the propeller, and that is the pitch ratio. Blade area ratio is the developed area minus the pause area. Developed area is, let us draw four blades of a propeller. Developed area means area of all the blades, area of all the blades plus the area of the pause, that is called the developed area. So blade area ratio is developed area minus the pause area, means only the area of the blades is taken in the numerator. Only the area of the blade is divided by the area of the circle cut out by the blade tips, area of this circle which the blade tip describes. That would be the denominator, and that ratio is called the blade area ratio. There is another ratio which is called the disk area ratio. This involves the denominator being the blade area plus the pause area, all the area blade and the pause. That is called the developed area divided by again the area of the circle cut out by the blade tips. Let us proceed further. Thrust power. Yes, in the power chapter of my first video in my channel, we had discussed the thrust power, wherein we saw that the propeller efficiency is expressed by the thrust power divided by the delivered power. This was one formula in the power chapter. However, here the formula is slightly different. Here the formula is thrust in newtons into speed of advance in meters per second. Please note this. This is where a lot of mistakes are made. Normally, the speed of advance, any speed of the ship, we take it as knots. But in this formula, since we are dealing with watts, which is a SI unit, we have to convert this knots into meters per second. How we convert from knots to meters per second? Say speed of advance is in knots. We multiply it by 1852 divided by 60. That gives us meters per minute. Divide by another 60. That gives us the speed in meters per second. So this is how we convert knots into meters per second. And another formula we have got delivered power. Yes, I will again repeat the power we had referred to in the power chapter of my first video. Proper efficiency was thrust power by delivered power. Here was one reference of the delivered power, but here we see it in a different format. Here delivered power is expressed as the torque into 2 into pi into revolutions per second. Now in both these formulae, we see that the power is in watts. However, if the thrust is in kilonewton, obviously then the power would come in kilowatts. Similarly, in the second formula also, if the torque is in kilonewton, the power would obviously become in kilowatts. Please note these units. Now let us do a simple numerical. A propeller of 4.5 meter pitch turns at 120 rpm and drives the ship at 15.5 knots. If the wake fraction is zero point 0.3, calculate the apparent slip and the real slip. So let us proceed. The theoretical speed is, we just saw, theoretical speed is pitch of the propeller into RPM into 60 divided by 1852. This gives us the theoretical speed, and here we get the theoretical speed as 17.49 knots. You may round it off to 7.5. And we have to calculate first the apparent slip. And the apparent slip, if you remember, just now we did, is theoretical speed, that is 17.49, minus the ship speed, which is given over here. Ship speed is given. This divided by the theoretical speed. This gives us the apparent slip, which turns out to be 11.38%. Now for the real slip. The real slip formula, if you remember, is equal to theoretical speed minus speed of advance minus divided by, sorry, theoretical speed into 100. Theoretical speed we have already got over here. We need to find out the speed of advance, for which we will take help of the wake fraction which is given over here. So from wake fraction, this is the formula for wake fraction, speed of the ship minus speed of advance divided by ship speed. From this, we get to know the speed of advance, which is 10.85 knots. And with the help of this, we put it in this formula of real slip, we get to know the real slip, and we get the real slip as 37.96%. So this is how the numericals in the propeller chapter could be solved with the help of, yes, some numerous formula that we just discussed. We can solve the numericals in the propeller chapter. Okay, thank you, and look out for more such interesting videos on my channel. Thank you once more for watching my channel.